Hello there, Mr. Sutton with the IM3 Honors 7-7 homework solutions on conditional probability with frequency tables. For number 1, we're supposed to create a frequency table based off the following information. So we have 150 students visiting a school canteen. That's a cafeteria for those of you not in the know. Some students have packed lunches, some have cooked lunch. 56 out of 89 who have packed lunch are female, and there's 72 boys. All right, so we need some rows and some columns here. So we have one way of breaking up the data, boys versus girls, and another way with packed lunch versus cooked lunch. So I'm going to make my boys, girls be the rows, and then packed versus cooked, that'll be my columns. And I've got a total column and a total row for each direction here. All right, so the information they gave me, 150 students. That's my grand total down here. And we have 56 out of 89 students who have packed lunch are female. So that means we have girl 56, and they said out of 89, so that means 89 total have packed lunch. They said there are 72 boys, so that means I'm putting boys 72 total as 72. All right, and now they didn't give us anything else, so we have to start filling in the information. So I'm going to start in the upper left here. If we already had 56 girls out of 89 with packed lunch, that means there must be 89 minus 56, or 33 boys who have packed lunch. And then that means there must be 72 minus 33, or let's see, I guess that would be 39 boys who have cooked lunch. And then I don't quite have enough information for this part yet, the girls who have cooked lunch, but I know that total girls is going to be 150 minus 72, so that's going to be, let's see, 78. And that means 78 minus 56, or 22, is going to give me the girls with cooked lunch. And then adding this up here, we've got 39 plus 22. That's a grand total of, let's see, 61. Yep, 61 students who have cooked lunch. Adding things this way, just to make sure it adds up to 150, we've got 89 plus 61. That does indeed add up to 150, so we're done. For number 2, we've got another frequency table problem where we have to make it ourselves. Felicity asked 100 students how they came to school one day. So the students walked or came by bike or car, and then we have boys versus girls again, a whole bunch of other information. So let me get my rows and my columns. I'm going to have a row for boys, a row for girls, and I'm going to have columns for, let's see, they're walking or biking or driving. So there's my possibilities. Now they said that there was 100 students overall, so that's the grand total. And we said 49 out of 100 students are girls. Okay, so that means that girls is 49 right here. 10 of the girls came by car, so that's 10 girl car cells here. And then 16 boys walked, so that's a 16 in boy and walk. 21 of the 41 students who came by bike are boys. So that means that we have 21 boys taking bikes and 41 overall. And then we want to create the rest of this on our own. Okay, so I don't have enough information for this cell right here, but I know that if there's 49 girls, there must be 51 boys to get to 100. And now we've already used up 37 boys in terms of walking and biking, so that means there must be 14 left over to take the car. We don't have enough to know how many girls walked, but we can figure out how many girls took a bike. That was 41 minus 21, so 20. And now we can backtrace our steps here to get the number of girls who walked. There's 30 girls who didn't walk, 49 overall, so that's 19 who walked. And that means there's a grand total of 35 who walked. 35 plus 41, let's just add this up. This is 24, right? And then 35 plus 41, that brings us to 76 plus 24 does add up to 100, so we got it. For number 3, a local driving school records the results from a month of driving lessons. So we have rows for people who passed versus failed, and we have columns for people who had under 20 lessons versus 20 or more driving lessons. So let's fill out the rest of this table, and then we'll answer some questions. First cell that we can fill out is the under 20 and still passing one. We've got 30 minus 21 is going to give us 9 for that. We don't have enough to know how many 20 or over people failed, but we do know that a total of 60 people failed, 90 minus 30. And that can backtrace us now to get this number. 60 minus 45 is 15. And now let's just add things up in each column. We've got 54 who had less than 20 lessons, and this is 36 who had 20 or more lessons. Given all that, let's now figure out this first one. A student was chosen at random. So that means that we're using 90 as our denominator with whatever we come up with here. Find the probability that they had fewer than 20 driving lessons. So grand total of 54 students had less than 20 driving lessons. So our probability then is going to be 54 out of 90. And then we could actually reduce this by, let's see, this reduces by 9s. This is really 6 over 10, which we could call 0.6, or we could do it on the calculator, either way. For part B, suppose a student was chosen at random, find the probability they passed the exam. So we're taking a look at all 90 students because they said a student was chosen at random. There's no other conditions. And we want the probability they passed. So we look at our pass total, that's 30. So our probability then is 30 out of 90, which I know without a calculator is going to be 0.333. For part C, suppose a student's chosen at random, find the probability they took more than 20 lessons and passed. Again, since it's a student being chosen at random with no other conditions, 90 is the total group of students that we're looking at. So this is our denominator. Now we want the probability they took more than 20 lessons and passed. So more than 20 and passed is just this one cell right here, 21 out of 90. And now whatever that comes out to on the calculator. So 21 out of 90, that's going to come out to 0.233 and some change. So there we go. Oh, and one more little thing. This should be greater than or equals, not greater than. All right, now we're good. For part D, Alan says that having 20 or more driving lessons helps a person pass the exam. Is he correct, and why? So there's a lot of different ways to slice the data here. One way to do this is to look at the number of people who passed and figure out how many of them had 20 or more lessons. If we do that, if we find the probability of 20 or more given passing, that's 21 out of 30, which is really 7/10, which is really just 0.7 or 70%. So that's a pretty good percentage. So out of the people who passed, more than them took the lots of lessons versus not taking a lot of lessons. But let's also look at the number of people, at the people who failed. What was the probability that someone took all these lessons, more than 20 or more, given that they failed? Well, that's a probability of 15 out of 60, which is 25%, 0.25. So it definitely looks from this data like having 20 or more lessons is going to help us here. So that's going to be, Alan is correct, 70% of the people who passed had 20 or more lessons versus 25% of the people who failed. And just one more thing for the sake of accuracy, this should be greater than or equal to 20 on both of these, not strictly greater. Okay, moving on. For number 4, we have to fill out this table and then answer a few questions about bookings made on one Saturday at some travel agency. So let's start here. So we've got a row for cruises and a row for bus tours and columns for Europe, Asia, and the Caribbean. We have a 28 total for the cruises. There's already 23 people accounted for, so there's 5 left who must have gone to the Caribbean cruise. Now for bus tours, 15 out of 18 in Europe went on a cruise, so that means the other 3 must have done bus tours. For Asia, there's going to be 6 people who did bus tours to add up to 14 total. And let's see, we don't know enough to figure out the number of people who took Caribbean bus tours, but we know overall there must be 12 people who took bus tours because the other 28 people took cruises. Now we can work backwards. 12 minus the 9 that's already accounted for with bus tours gives us 3 left over for Caribbean bus tours. And then finally, 5 plus 3 equals 8. Now we add this row just to make sure it adds up to 40. So that's 18, 32, 40. Awesome. Okay, let's take a look at our first real question here. One of the bookings is chosen. Calculate the probability of choosing Europe. So they said one of the bookings. That means one of this 40 total here. So this is our denominator. Probability of choosing Europe. Well, 18 people chose Europe overall. So this is a probability of 18 over 40. And what's that going to come out to on the calculator? Looks like that's coming out to 0.45, so 45% of people chose Europe. For part B on this question, we want to know the probability of choosing the Caribbean out of all the bookings. So again, 40 is our denominator, and we're just looking at the Caribbean total. 8 out of 40 is that probability, so that's going to be 0.2. For part C, one of the bookings is chosen, so again, 40 is the denominator. We want the probability of choosing a bus tour. So there's only 12 bus tours out of 40, so that's our probability. So this is really like 3 out of 10 or 3/10 or 0.3. For part D, a cruise booking is chosen, so that's some very important wording. Calculate probability of choosing a trip to Europe. So if we're doing cruise bookings, that means we're finding the probability of Europe given cruise. So that means that we can only look at this cruise row right here that had a total of 28. So this cruise 28, that is our new denominator. And now we just want to know how many out of those 28 went to Europe. So that's a probability of 15 out of 28, which we'll do on the calculator. And that comes out to 0.536. For part E, cruise booking is chosen. So that means 28 is our denominator because we're only looking at the people who took cruises. Probability of choosing a trip to Asia. So that would be 8 out of 28 for probability of Asia given cruise. And let's check that on the calculator. So 8 out of 28 is going to be about 0.286. And then finally for part F, we want the probability of choosing a trip to the Caribbean given that you're doing a cruise. So Caribbean cruise, that's kind of the big one that a lot of people like to take. But in this table, not a whole lot of people. So that's going to be a total of 28 that we're doing for our denominator. Only 5 of that 28 took a Caribbean cruise. So 5/28, and we'll see what the calculator has to say. So that's going to be a percentage of 0.179. So about 17.9% took a Caribbean cruise if they were going to take a cruise. For number 5, while Jim is at the park, he observed the activities of 50 people. Below are his data. So we need to fill in this table, and then we can answer a whole bunch of questions about Jim's table here. All right, so we'll do water activities first for males. Now we have 2 rows here, one for males, one for females. We have a column for tennis, water activities, and picnic. So male water activities here. There was 28 males overall. We're subtracting the 16 already accounted for. So that's going to be 12 left. And then down here, let's see, we have 7 people who went on picnics who were males, 18 overall. That means 11 must have been females. Adding up everything in this row, we have 11 plus 11, so 22 females overall. And now we can fill in this bottom row. We have 12 people playing tennis, 20 people with water activities, and then we have 50 people overall. And they said 50, so they actually gave us that. We just kind of forgot about it because it wasn't a word instead of a number. And now let's just double check here. So 28 plus 22 does add up to 50, so everything checks out. All right, so suppose someone was partaking in water activities. Key wording here. Find the probability that they're male. So partaking in water activities, we're basically asking for probability of male given water activities. So we're only allowed to consider the 20 people who were partaking in water activities. Out of them, 12 were male. So our probability then is going to be 12 out of 20, which is really 3/5 or 0.6. For part B on this question, we want to know if someone's partaking in water activities, what's the probability they're female? So again, water activities, only 20 people are actually doing that. So that's our denominator. And out of that 20, 8 are females. So 8/20 or 2/5 or 0.4 is the percentage of water activity people who are female. For part C, suppose we randomly pick a male. Find the probability they're not playing tennis. So we are only allowed to consider now the males, the 28 males here. And out of that 28, how many are not playing tennis? So tennis is 9 of them. So that means 12 plus 7 of them are not doing tennis. So our probability then of not tennis given male is 12 plus 7 over 28. And now we'll just do that on the calculator. And as always, if you're adding things in the numerator or denominator, make sure you use a parentheses if you're just doing straight up division instead of the fancy fraction form. Now we have 0.679 for that percentage. For part D, for number 5, suppose we randomly pick a male. So again, we're using 28 as the denominator. Find the probability they're having picnics or playing tennis. So we're looking for probability of picnic or tennis given male. So out of that 28, how many are doing picnics or tennis? We've got 9 plus 7 out of 28. And that's 16 out of 28. We'll do that on the calculator. So that's going to come out to about 0.571. For number 6, Carol records some cars that pass by her house. She must be very quick at spotting these things. So we've got Volvos, Renaults, and Fords in the columns, and she's got colors for each of the rows, gray, red, and blue. This is a nice big table, 3 by 3, at least for the original data. So now let's fill it out, and then we can do the rest of the questions. There were 31 gray cars total, and we've already accounted for 23 that are not Volvos, so that's 8 that must have been Volvos. Moving down to this spot right here, red Fords. Well, there were 15 red cars, so 23 minus 15 leaves us with 8 Fords that are red. Down here, we've got 12 Volvos. We've already accounted for 12 of them, so there's no blue Volvos. Renaults, we don't actually have enough information to fill this out yet. Let's move again to here. For Fords, there's 25. We used up 22 of them, so that means there must be 3 that were blue. And total blue cars, well, we had, 54 cars total, or 54 cars that weren't blue, 60 total, so that's 6 that must have been blue, which means that there must have been 3 blue Renaults. All right, let's fill in this last one here. So adding this up, we've got 9 plus 11, which is 20, plus 3 is 23 Renaults overall. And now let's just double check it going the other way. So 12 plus 23, that's 35, plus another 25 brings us to the grand total of 60 that we were expecting. Now that we've got our table filled out correctly, one of the cars is chosen. We want to calculate the probability of choosing a red car. So one of the cars, that means 60 is our denominator. This is the total group of cars we're looking at. And we just want to know how many of those were red. So 23 out of 60 then would be our probability of red. And we'll do that on the calculator. 23 out of 60 comes out to 0.383. For part B, one of the cars is chosen. We want the probability that it's a Volvo. So again, we're looking at the whole group of cars, 60, because it said one of the cars. And how many of those are Volvos? We have 12 of those. So 12 out of 60 is our Volvo probability. That's actually 1/5 or 0.2. For part C, one of the cars is chosen. So 60 is our denominator. Probability of choosing a Ford or a Volvo. Well, there's 12 Volvos and 25 Fords, so that's 12 plus 25 over 60, and we'll use the calculator for that. So then I'll just save us a little time. 37 over 60 is what we're doing. Comes out to 0.617. For part D, a Ford is chosen. Very important wording here. Based on that, we want the probability of it being blue. So we're looking for the probability of blue given that a Ford has been chosen. So that means that we can only look at the Fords here, of which there are 25. 25 is our denominator. We're just asking how many of that 25 are blue. Well, there's 3 out of 25 that are blue. So on the calculator, let's see what that comes out to. That's going to give us 0.12, so 12% of the Fords are blue. For part E, a Ford is chosen, so that means the Ford total, 25, is our denominator. Calculate the probability of it being red or gray. So in other words, not blue. So we've got, 14 plus 8 over 25 for our probability of red or gray given Ford. And actually, we already calculated the probability of it being blue on part D. We saw that it was 0.12, so this is just going to come out to 0.88 then, but you can confirm it on the calculator if you want. For part F, a Ford is chosen. Calculate the probability of it being not blue. We actually just kind of answered this question in disguise. Again, since a Ford is chosen, we have to look at the total for Ford. The 25 is our denominator. Not blue is just going to be the 14 plus the 8 for the gray and the red. But we just calculated that on part E. Again, that's going to be 0.88.